Hello guys, so today we'll be starting pulleys, right? The last part of machines that we have left around and we couldn't do that last week, so we decided to finish it within this week only, so we don't waste time and we finish it within this week. In fact, I'll try to do it in a better way than maybe I would have done it in the class. Okay, so let's start. What is pulley first of all? Look, if you go about pulleys, I would remember those movies in 1990s where we used to see those whales were there, and well, I'll say a bit of caste system now, though I am a Brahmin, still then. You would remember, those of you who have seen the movies in 90s, there was बड़ा बड़ा कुआं, ब्राह्मण के घर में कुआं है या ठाकुरों के घर में कुआं है, जिसमें जो गरीब जो गांव का आदमी है वो जाके पानी नहीं निकाल सकता है। उस कुएं में एक पुली रहता था, उस कुएं में एक पुली रहता था जिसको ऐसे खींचने से, और एक साइड में बकेट लगा रहता था, that bucket was going inside the well, and if you pull it from the other side, it was like this. If this was the bucket and you pull it from this side, then the bucket will come up filled up with water. Okay? So there were some wells where the lower caste people were not allowed to take water from. Still in India there are some places where this happens. I shouldn't say it right, but yes, it happens in some places. Okay, so that is the basic thing of pulley, nothing else. उसी से हमको पुली पता चला था. When I was young, I understood pulley from that one, not from the books. So nowadays there are no wells at all. So most of us will learn pulley for the first time from the book, right? From your syllabus, and that is a pity. Okay? That is a pity because we learned pulley from the practical aspect. Though we saw it in movies and we saw it in our household items also, because in various relatives that we have in our villages, there we have seen it. But nowadays it is almost obsolete. People don't see because हम तो lazy हो गया भाई. ऐसे खींचेगा कौन खींचेगा? स्विच दबाएगा, पंप चलेगा, पानी ऊपर जाएगा, नल खोलेगा, पानी आएगा. So we have become lazy, and that is why we are learning little. Previously we used to work hard, we are learning more because जिसमें आपका sweating ज्यादा होता है उसमें आपको याद ज्यादा रहता है. So let us directly jump into the subject without wasting any further time on the lecture that I was giving on this philosophy. Okay, so in pulleys, in your ICSE syllabus, there are basically three kinds that we have to study. One is fixed pulley, number two is movable pulley, and number three is block and tackle pulleys. Okay, so these are the three kinds of pulleys that we are going to study, and if time permits, I'll go and try to explain some other types of pulleys that are also there but which are not inside ICSE syllabus. So I'll cover that afterwards, not now. So let us go into the pulley part. So the first pulley that we are going to discuss right now is single fixed pulley. So what is single fixed pulley? A rigid frame, that is a rigid support that will be there. Okay. From that one axle, okay, axle is this one, basically axis of rotation of the pulley. So this is basically holding the pulley together in a place. Okay. So this pulley, if you see, this is basically fixed. This pulley, this circular part which is called a pulley, is basically fixed and it is not moving. It cannot move. The pulley itself cannot move. And this is the string attached to the pulley. This can move, right? This can move, and that is that movement only we will use for our convenience. Okay. Now this is the thing that is basically holding the pulley with the rigid frame and making the pulley fixed pulley and not movable pulley, right? Okay. Now let us come into two very important things that is done in class 9 and you should always remember in your life. Okay, this will be very important. Number one is action reaction. What is action reaction? Nothing except the Newton's third law. हर एक्शन के लिए एक ना एक तो जैक्शन होगा. समझ गया ना? Action means if there is any action, then there will be reaction. तो इसका नाम दिया action reaction. And another important thing for string if there is a single string, remember, if there is a single string, that is this one, this is a single string, right? This is not two strings. इधर पे एक string ऐसा नहीं है. This is single string. একটা দড়িতে একটাই टेंशन. What does this mean in English? बंगाली में जो लोग समझ रहा है उसको तो समझ में आ गया. Now some people doesn't understand Bengali nowadays. Okay. Anyhow, একটা দড়িতে একটাই টেনশন. This basically means if there is a single string, there will be same tension in that string all over it. Okay, same tension all over it. The tension value will not differ if there is a single string. ठीक है? If there is a single string, the tension value will not differ. ठीक है? It will be same tension. So why do we need this? So there are two things. One is for every action there will be a reaction, that is opposite reaction, and for every string there will be single tension. That means একটা দড়িতে একটাই টেনশন, আলাদা আলাদা টেনশন হবে না. ঠিক আছে? সিঙ্গেল একটাই টেনশন হবে. Now let us go into it. Now what are the actions first of all? We have to find out. Then we'll go into finding the reaction out of it. So the action over here is load, right? Load is the action. Load is giving some action onto the string. So in string action के अगेंस्ट में कौन सा रिएक्शन काम करता है? टेंशन. 9th में पढ़ा था ना फोर्सेस में. So this is the tension T. For this part of the string there is effort, that is E, which is producing the action. So which will be the reaction? This one. This will also be T because this is same string and একটা দড়িতে একটাই টেনশন. তো একটা দড়িতে যদি একটাই টেনশন হয় তাহলে এখানে যদি T হয় তাহলে এখানেও T হবে. ঠিক আছে? If this tension is 50 Newton, this tension will also be 50 Newton and nothing else. Okay? So that is why I have given this name to this one so that you remember this for your life. And একটা দড়িতে একটাই টেনশন, this I have written in Bengali. So because as most of you are Bengali, it is very easy to connect with you. That's right. Okay. So basically you can say একটা দড়িতে একটাই টেনশন, or you can also say every single string will have no different tension. It will have same tension. If there is a single string, it will have same tension all over it. Next. So what have we found? We have found out there is four forces T, L, T, E. So if you consider an equilibrium condition means suppose what did Newton say in his third law? Every action has equal and opposite reaction. So what was the action over here? L, right? L was the action. It is having equal and opposite. Opposite क्यों है? क्योंकि उसको opposite side में act कर रहा है, तो opposite ही होगा. And equal also. Opposite and equal. तो equal मतलब this L and T has to be equal. Similarly, इसका action क्या है? E. इसका reaction क्या है? T. न्यूटन ने बोला दोनों इक्वल होना चाहिए, तो होना चाहिए. ठीक है? वो तो लॉ है. ठीक है? L is equal to T, E is equal to T. हो गया. Now we have to find out the parameters that we have learned for machines. How to understand what is the use of the machine. इस machine को हम क्यों यूज कर रहे हैं, उसके लिए क्या क्या पैरामीटर हमने पढ़ा था? मैकेनिकल एडवांटेज, वेलोसिटी रेशियो, and efficiency. So first we'll do mechanical advantage. What is mechanical advantage? Load by effort. Now what is load? T. What is effort? T. So it will cancel out and become 1. So here in single fixed pulley, mechanical advantage is 1. What does this mean? It is not a force multiplier. It is not a force multiplier. आपका फोर्स को ये मल्टीप्लाई करता नहीं है. ठीक है? नेक्स्ट, VR. What is velocity ratio? Velocity ratio is velocity of effort by velocity of load. इसका उल्टा है ना, इसका उल्टा, velocity of effort by velocity of load. What is velocity? Distance by time or displacement by time, to be very exact. So displacement by time, टाइम को आप 1 सेकेंड मान लो, टाइम को आप 1 सेकेंड मान लो, तो ये क्या हो जाएगा? DE by DL, राइट? टाइम को अगर हम लोग 1 सेकेंड मान ले, दोनों टाइम को, क्योंकि 1 सेकेंड में जितना डिस्टेंस ये जाएगा उसके हिसाब से इसका वेलोसिटी आएगा. 1 सेकंड में इसका डिस्टेंस जितना जाएगा उसकी सब इसका वेलोसिटी आएगा, ठीक है। सो डी बाई dl वी कैन राइट डाउन, वी हैव ऑलरेडी डन दिस इन क्लास, हाउ v by dl is coming, d by dl. Now let us find out if I pull this, if I pull this like this, suppose up to from here I am pulling it over here, so x centimeter, okay, x centimeter. So here full string is going to come x centimeter. This load will also go up by x centimeter, right? If you pull this one by x centimeter, this load is also going to go up by x centimeter. ठीक है? So dE, displacement of effort, if it is x, then displacement of load is also x. So velocity ratio is 1. So if velocity ratio was 1, then was it a speed multiplier? No. So it is still not a speed multiplier. It is not a force multiplier. It is not a speed multiplier. Speed multiplier नहीं है. Force multiplier नहीं. What is efficiency? ma by dr. Note down कीजिए पूरा. ma by dr is the efficiency. So ma is 1, vr is 1. So efficiency is 100%. Right? Now, see, from here, from this part, we have learned that it is not a force multiplier, it is not a speed multiplier. तो फिर Q इस मशीन को यूज करें. If it is not a force multiplier, if it is not a speed multiplier, मशीन को यूज करने का मतलब क्या है? There must be some reason for which this machine will be used. कौन सा? The reason lies here. It is always hard to improve yourself. आपका मार्क्स बढ़ाना बहुत डिफिकल्ट होता है, ठीक है? अपने आप को इंप्रूव करना बहुत डिफिकल्ट होता है. जिंदगी में ऊपर जाना बहुत डिफिकल्ट होता है, जिंदगी में नीचे उतरना बहुत इजी होता है ना? सीढ़ी से ऊपर जाना बहुत डिफिकल्ट होता है, सीढ़ी से नीचे उतरना बहुत इजी होता है. क्यों इजी होता है? सीढ़ी से ऊपर उठोगे यू विल बी वर्किंग अगेंस्ट द ग्रेविटी, सीढ़ी से नीचे जाओगे तो यू विल बी वर्किंग विद द ग्रेविटी. तो इधर से ऐसे पुल करोगे तो यू आर वर्किंग विद द ग्रेविटी, इसको ऐसे खींचोगे तो यू विल बी वर्किंग अगेंस्ट द ग्रेविटी. तो दिस इज जस्ट टू चेंज द डायरेक्शन, राइट? दिस इज जस्ट टू चेंज द डायरेक्शन. सो इसका यूज क्या है सिंगल हुक्स पुली का? दिस इज यूज फॉर चेंजिंग द डायरेक्शन फॉर आवर कन्वीनियंस, बिकॉज इट इज कन्वीनियंट फॉर अस टू पुल डाउन. इट इज जस्ट टू चेंज द डायरेक्शन. ये आपका पूरा हो गया सिंगल फिक्स पुली. क्या क्या सीखा हम लोगों ने? we have learned this is an ideal single fixed pulley. Remember, we have not considered any friction, we have considered weightless strings and weightless everything is absolutely smooth. There is no force of friction over here. This is an ideal fixed pulley. For an ideal fixed pulley, mechanical advantage will be 1, velocity ratio will be 1, it won't be a force multiplier, it won't be a speed multiplier, it will only be used for changing the direction of your action of force. That's it. Okay, so that is single fixed pulley for you. I hope you have understood it very clearly. Let us go into the next part in the next video.